And I get to take that long walk all the way over to where my clicker is. Good morning, everyone. Good morning. So I get to catch everyone up here because I'm in front of you in the next session. But that's cool. So good morning. My name is Patrick McFadin. I am the Chief Evangelist for Apache Cassandra at DataStax. And thank you, Peter, for leading in with a talk about open source databases, which is what I work on, of course. DataStax, we are a company that loves Apache Cassandra, but we do a lot of other things too, like Apache Spark and Kafka. We work with Solar, Apache Solar, so we really like a lot of Apache projects. So why am I here today? Well, this is my background. My background, of course, is all of these databases, and I've made a living doing those for a long time. And so all of those technologies I've broken horribly in production. I'm sure many of you have too. But along that journey of me trying to make things work in a large scale, trying to scale, get things working environment, I also started working with another database technology called Apache Cassandra. And so I've been working with Apache Cassandra for about 6 years, not exclusively, but as of late, because I work for DataStax, pretty much. But why would I, a relational database administrator and a developer, why would I get involved with something like Cassandra? And it's interesting. I mean, you probably look at me and it's like, well, are you a trader? No, I'm trying to recruit people. And I wrote this a few years ago, and I realized as I was doing consulting work with Cassandra, I'm realizing that all the developers are pretty much running the databases, and I flipped out a little, and I wrote this blog post. And this blog post was really meant to be like an appeal. Like, I think I wrote it in an airplane on the way back from a consulting trip. I was like, man, we need some DBAs. Now, I said Oracle DBAs, that could be anybody, right? But I really needed some professional help here, not like that. You sound like my wife now. But what I meant was we need people that know how to run databases to help start running databases. Now, I know you probably are thinking, no, all right? That is not a good idea. And you're probably judging me a bit for being a bit of a traitor. Hey, you left relational world and went to this craziness. If you're going to judge me on some of my really previous work, like the stuff that I did with FoxPro. And if you're going to, as long as we've got the judgment book out here, you can judge my boss who made me migrate the FoxPro database to Microsoft Access. All right, I'm not bitter about that, but that happened, right? And I'm not going to relive that right now, but, I know I saw some FoxPro people out there like, yeah, FoxPro. So along that way, all right, so this is, all right, if you notice, this is like 90s. It was a good time for database people because we were all making like millions of dollars on every project, and then it disappeared whenever the .com crash happened. I saw that slide that Peter put up, and I had that moment because I went through the .com crash. We were all riding high on this .com thing. It's like, we're taking over the world, it'll be amazing, and then boom, everything died out. And so we started doing new things, right? It's like, oh, well, let's build a company that has a profit motive. And along that way, I worked on a lot of big systems and got to build some really cool things. Oops, not that, this. So with Web 2.0 and the scaling and trying to make things happen with a better purpose, which is not cratering out as a startup. So along that way, really, Microsoft Access, why did they make me do that? Oh, hey, Clippy. If a database needs Clippy, you should not use it. So along that way, this happened. Does everyone remember where you were on this day? Think about that. June 29th, 2007. Huge day. And for people in infrastructure, you had a bad day that day, because that was the day that Steve got up there on stage and said, you're going to buy 1 billion of these things, right? And man, did that change everything. Now, I know where some of you were probably on June 30th in line to get one. But this was a big deal, because we were going from web browsers, which were contained, to these things, which were completely crazy. If you think about where people were doing their stuff, they had to go home or get on the internet to do their thing at home, but now they could do it anywhere. You know who got hurt the worst on this? Banks. If you ever worked at a bank, you knew that there was this wonderful thing called batch at night. We'll just shut down the computers at night. No one banks at night. Well, they are now, right? And that's a problem. So we had to deal with this as a team, people who work in infrastructure. We're going to have to deal with 24/7 apps, because if your app is not online, your competitor might be. And then the App Store has this great feature. It'll help you find the next app that's just as good as yours. That's not so good. So when we started scaling our infrastructure to make this work, here's the problem. You start out with a server. Looks great. Oh, we need more power. Great. We will get a bigger server. That's the solution, right? The bigger server. And that's called, vertical scaling. And of course, this is my throwback to my E450, which I really loved. Son, I miss you. But that was the big server. And then when you ran out of that server, you dial it up and you get the bigger server. Awesome. But eventually what would happen is you would run out of more. There was no more big. There's no more big. And then what would you do? All right, we'll just leave that alone for right now. Well, what I used to count on was this thing called Moore's Law, right? I knew within a procurement cycle, I would get double the power. Oh, I hate to rain on your parade, but that's dying out too. Moore's Law is kind of flattening out. Now, Moore's Law, for those of you who don't know, Gordon Moore from Intel, he did this kind of like random thing that he predicted that every 18 months the computing power would double. And it was one of those things he just tossed out there that worked out for a long time. But it depended on the fact that feature size on transistors were getting much smaller every rev as well. And we're running into this thing called physics, where you can't get much smaller. So we're going to have to shift a whole other type of computing, which is optical quantum, something like that. But we're running out of that. So we can't count on that anymore. And as a matter of fact, right now in the Valley here, if you live in Silicon Valley, this is a very popular betting game. It's like, doing brackets for Final Four or working on or betting for a World Cup. It's when will Moore's Law actually end? And what's funny is I noticed on this graph that Gordon Moore actually has 2 bets. I guess since you invented it, you can have 2 bets. But everybody's betting on the end of this. What does that mean to you? Well, that means that you can't count on that doubling of power all the time. And what do we get now? Well, we've changed the game. And this is what we've started seeing in the past, say, 10 years, is instead of looking at a single computer and then scaling that upward, upward, upward and making it bigger, why don't we bring together a group of computers and call that a cluster? Now, I think that's a pretty good idea. Now, my background is in distributed computing. I have a degree from Cal Poly. Not one person said yo. All right. But I believe in this, right? Because that means that whenever a client says, hey, I need to connect to a big computer, it connects to the cluster. It just thinks that it's connecting to a big computer. Now, what's really cool about distributed computing is that when computers work together, we know that it's awesome. Oops, not so awesome, right? That was a bad example. However, here's my other point. You know what was funny about the Terminator and Skynet? Skynet was this massive distributed computing system, so powerful it killed off humanity. Well, there's a little problem. It was also a single point of failure. Did anyone see Genesis? All the rebels ran to this mysterious place that looked a lot like the Oracle headquarters, and they blew it up. And Skynet was dead. So, there's Clippy again. So single points of failure. That's bad, right? Even though it was a distributed computer, it was in one place where the rebels could blow it up. So Redwood Shores, Cyberdyne. That was one place that you could go. So Apache Cassandra. This is what's come along through the years. And this is what I talk a lot about. Apache Cassandra was built around all of these ideas that are bad and what can be fixed with engineering. And it's built on this premise of shared nothing. Every node is independent, but works together as a team. It's peer-to-peer. And when you need capacity, you just add more nodes. So you get that client that thinks, oh, I'm connected to the really, really big computer. And this is real distributed computing. This is not distributed computing. I was a charter, If you're a sharder, that's okay. I admitted it, and I built some really amazingly exotic failure modes into my systems based on this. And this can work for some use cases, but not all, because what you wind up is you give up a lot of things with this. There's a lot of trade-offs with doing sharding. So Apache Cassandra, the way that it is meant to work is it is, and I'm going to walk through this really simply, but the distribution is base. The replication is base. It's built into it. So when the client says, I want to write some data to the cluster, it just writes it to one of the nodes, any node. And that node will asynchronously copy to the other replicas. And then that node will asynchronously copy to another data center, which will asynchronously copy to those nodes. And all of this is done with consistency models that you can program and you can call with reliability so that whenever you do it, you know you have at least some assurance in your own mind that these things are happening. And it's done with computer science, not just a crazy idea. And it works really well. If you came today thinking, I wonder if Cassandra works, it does. We can just not have that conversation. It works great because there's plenty of companies that rely a lot on Cassandra to work. It's just understanding how it works. Now, why is it now? Why is this something now? Now, I mentioned the iPhone. Here's the other, and probably the biggest reason, cloud, right? When I started using cloud, everyone thought, oh, it's another fad. Yeah, all right. Just like Docker's a fad too, right? But this cloud adoption is happening. Now, it used to be just these startups that were doing this, and that was fine. But now you see these large enterprises. You hear about these big companies moving to the cloud because they realize that it's not cost effective for me to own floor space. And this will continue to happen. Now, with that, there comes this irrational feeling that if I move to the cloud, it's going to be awesome, right? Not so awesome. Cloud has just as much problems as you could ever put in your data center. And believe me, I put plenty of them in mine. Look at that, which means this was an amazing graph. I didn't know this even was that bad. But cloud goes down a lot, and it's for reboots. Anyone else experience the AWS reboot? Remember when Amazon did that? Oh, yeah, I got a lot of, yeah. Amazon did that for us as a service. You paid for that. And they rebooted a ton of servers. It was a big deal. And what happens is that you get to say this, the cloud is down. Now, what happens when the cloud falls? What do you call that? Fog. That's just one bad joke, right? Of course, I have HP Cloud on here. Too soon? All right. So, cloud fails. Just get over it. It will fail. If you have told your boss that the cloud is amazing, it's 100%, you just lied because it won't. But there's a way to handle this. Do this. So there's companies that like Netflix with their chaos monkeys, the Simian Army. Everyone heard of them, right? How about a little less known as CMorg, the worst named project ever, from LinkedIn. What do these do? They're failure injection frameworks. They are designed to break your infrastructure on purpose. Netflix talks about this. It's a great talk, right? It's like, we built this thing to destroy things in production during the day. That freaks people out, right? Can you imagine your job? You walk in one day and you're looking at the sprint planning board and, hey, Patrick, your job today or this sprint, I want you to build something that breaks everything. I'm like, what? That's like every day, right? That's like falling off a log. I can do that. So they've built that. And why? Because they want to know how things react when it fails. So if you take a server, just go in there and unplug it. What happens? When you inject latency, what happens? And that's what you should be thinking about all the time anyway, regardless of what technology you're using, because this is just reality. Things fail. One of my favorite things to do as a consultant when I'm talking to big company X is I ask them, can I walk into your data center and unplug anything? And they look at you like, whoa, dude, what are you doing? That's terrorist act. What are you talking about? If they have that reaction, I'm like, you are not ready for this. It's kind of like this little Zen moment. You are not ready for the Zen. But they have to think about it. What happens? And if I hear these companies that have a freeze, like you have to get VP approval to walk into the data center during a certain time of the year, you're in a bad place. So who counted on this? Well, people who brought you the cloud in the first place. Amazon. They're like, you know what? We're not going to lie to anybody. We're just going to do this. And Dynamo Paper was built around this idea of failure. Amazon loves money. They love it. And what do they have? A box that you click on, say buy now. And if that isn't working, they're not making money. So they put some pretty heavy-duty brains to work on this thing about how you keep a database online, performant, and reliable, and consistent. Dynamo paper, 2007. When this hit, those of us in this field were like, it was almost like this ray of sun from the heavens. Ah, here's this thing called Dynamo. Look at this. So many databases have used this, or at least some sort of technology. Cassandra, of course, is one of them. React, Voldemort, or others. There's another one called Dynamite, which is a memcache thing that runs on the Dynamo model. It is a very reliable model. And why do I need to think about this? Because your globalization, this is another thing Amazon was thinking about, and you should think about. Because whenever you first deploy your application, people may be just local to you. If you're in the US, maybe it's in the US. But as you hopefully grow, you need to think about where your customers are. And having that strategy in place really makes a lot of sense. Because when you need to talk to somebody in India, it's 250 milliseconds from San Francisco to New Delhi, latency. It exists. So you need to be closer to them. That's a lot of latency because this planet is really, really big, and you can't get away with faster. You have to be closer. That's just it. So how fast do you think a photon, one photon of light, traveling or circumnavigating the globe, going around really super fast in a vacuum, it takes 133 milliseconds to do that. You can't, that's the law, right? Think you can break physics? Oops. You notice that the yes is grayed out? Can't do it. Talk to Einstein if don't believe me. So this data protection, that's the other part of this that is really interesting. We now have a way, with Cassandra, we have replication. And this is probably a newer problem. But the world is starting to wake up to the fact that global data is there. And then they're going, it was like excitement. Oh, wait a minute. My data is not in here anymore. So like the EU flipped out last year. And they're like, hold on. Companies from the US are seeing this data. That means the NSA's got it. That's exactly what that means. So there's these laws now that are coming up, and you have to think about how you control your replication. So things like a product catalog, yeah, spread that all around the world. There's nothing private in there. But something like data for customers needs to stay inside the EU. The EU has just deemed that. That is the way it will be. And a lot of companies are using this. And Apache Cassandra allows you to control your replication in that way so you can keep things inside borders. So hopefully I've convinced you a little bit that this might be a good idea to think about at least. And join me a little bit if you can. But what do you do now? Now what do you do? Well, this is the important thing, is just understand how it works and learn. I work for DataStax, like I said, but we have this free resource called DataStax Academy. It's free. You can get on there and you're going to learn all about how to work with this. And you can get on there. I will teach you how to do things like data modeling. I just did a little thing on data modeling the other day here at Percona Live. And I'll teach you how to, this is schema. This is actual real schema in Cassandra. It's not a schema-free database. There's columns, and there's types, and collections, and it's real schema. And that's for the developers. For the operators, for DBAs, I'll teach you how to do really exciting things like compacting SS tables. I look super serious on there, but I swear I am not. But I'll help you do all this stuff. And when you're ready, when you really want to take it to the next level, you know what you need, certification. And O'Reilly does that right now. I think that's what's really cool, is that we've got this great community of people who are building out resources and making it so that professionals can do this. So as I said, this is a group effort. This is Apache Cassandra. DataStax does not own Cassandra. We are just one of the people, or one of the groups that really love it. But you, as people, a part of the community, I would invite you, join our community. We have a really robust community, and we help each other, and we try to help each other get farther. But more importantly, we take input, and we listen to people, and we have a great issue tracker on Jira's. Or, I know if you hate Jira's, I'm sorry, but we do see some really neat things from the community about what do we need to do next? Where does the product need to go? And that's the best part of this project, is the community. And So what I'm going to leave you with is, how are you going to build your next amazing app? It's probably going to be in the cloud. How are you going to do it? And I would like to help you if I can. So let me help you if you want, and thank you very much.